Hi class, this is Neil, and this is the second video in lesson 4. We'll look at the definition of independent events, and then we'll look at one of the practice problems. So the definition of independent events, like we discussed before, is events that are not affected by previous events. So if you think about the most basic example that's often given in probability, when we flip a coin, if you land on heads the first time, that doesn't affect what's going to happen the next time you flip a coin. And that's a really important idea. This is the statement that we use to look at the last example problem. If the probability of A is equal to the probability of A given B, then A and B are independent. Okay, let's look at practice problem 1. So the results of a survey of the student body at Central High School about television preferences are shown below. Then we have all this information from the survey. Are the events student is male and student prefers reality series independent of each other? Well, we're going to use this statement to prove it. So, independent means the probability of A is equal to the probability of A given B. They're the same. So in this example, we can define A as being the student is male. We can define B as prefers reality series. Okay, so first, the probability the student is male. Well, if I look at my table here, I see that there's 230 males out of 490 total students. So there I would just calculate 230 divided by 490, and I get to the nearest hundredth 0.47. Okay, so next, really all we need to calculate is what is the probability of A given B? So if we write that out in words, what that really means is, what is the probability of male given they prefer reality series? All right, so if I look at my table here, I'm only interested in those students that prefer reality series. Out of those students, 70 are male out of 180 total students. So the probability of A given B is the same as 70 over 180. And we see that equals to the nearest hundredth 0.39. Notice they're not the same. And I've run out of space, but what we really need to say is that the probability of A does not equal the probability of A given B. Therefore, the events are dependent on each other. That's it.